So good afternoon students. Last class we have started with an introduction to embedded system, which is the first topic under your unit number 1, and today let us discuss about the structural units in an embedded processor. So when you take a processor for your embedded system, what and all it is required, or what and all the structural units in an embedded processor, that we will see. Then we will discuss about selection of processor, on what basis you try to select a processor, and then how you select your memory devices, and then we will discuss with DMA. So today we will discuss this three topics. So one is structural units in embedded processor, then selection of processor, memory devices, and then DMA. Okay, so when you say as a structural unit, what and all should be present. So when you take an embedded processor, internal bus, internally inside a processor, even till today we are using only with parallel communication. Okay, there are, I think you know that there are two types of communication. One is parallel, another one is serial. Parallel, it is fastest way of communicating than serial, but it has some drawback. So when you want to communicate from one system to another system, when you go for parallel, then you have to run so many wires, and that is not that much easy. So if even you take as a 8-bit, 16-bit, 32-bit and 64-bit, it is practically speaking, it is little bit difficult. Okay, so what we will do is we will go only for serial communication, whereas when you see inside a processor, I can put a parallel. Okay, so by that case, if I put parallel, then the speed will increase. So and that also I will put with the gold or silver material, because it has less resistance. Why should I have less resistances? To reduce the power consumption. If I am putting by with some other material, what will happen is it will draw more current, which means more power, and even more temperature will be created, and that will destroy my device. Okay, since from the first class itself we say all semiconductors devices which are manufacturers are based upon silicon and such things. It is not a pure conductor, so some amount will be generated as an heat, and this heat dissipation is a big task. That is why you have a fan over your processor. We call it a CPU fan. That is because it has to drain the heat from that particular processor and throw it out. So internal bus should be always, you remember that it is parallel. Why we are going parallel is, by when you go parallel, the advantage is very fast way of communication than serial communication, but you require more number of lines. Okay, it is an 8-bit, means we can understand that there are 8 lines running. If it is 16-bit, it is 16 lines running, and if it is 32 lines. And nowadays in our motherboard, when you say the motherboard, it has 64 lines of address buses. Okay, so address bus 64-bit is indicating that address. Even today we will go only for 8-bit or 16-bit data lines, but only address lines we will increase. I will tell why we are increasing the address bits. Okay, next comes address bus. It is an external bus that carries the address from the memory to the inbuilt memory, as well as input output device or other unit of the system. Okay, you call it as a motherboard, where you will have a processor in center and all other peripherals which is required, and this communication also will be by parallel, because it is inside the board. So we doesn't bother about the number of lines, and we can only bother about the speed of communication. Okay, if we assume that if you have one address lines, then you can address 2 memory location, which means if I put 0, then first location of my memory. If it is 1, it is second location of memory. So 2 to the power 1 is nothing but 2. So if you have one address lines, I can address the memory of 2. okay, which means the 2 is the address of the memory, not the capacity of the memory, that you have to remember. Okay, I am not telling about the capacity of the memory, I am only telling the address of the memory. Okay, so capacity is again an 8-bit or 16-bit or 32-bit or 64-bit you can store in a single data. Okay, so that is depending upon the memory size. Okay, if you take memory, the thing which you have to remember is how many lines are there in memory, and each line how many bits can be stored. So if I have only one address line, it is 2 to the power 1, which means 2. So either from processor, if I say 0, then I am pointing the first memory location. See, I am only pointing the memory location, not the memory width. Memory width is again, either it can be 8 or 16-bit. Okay, so please try to understand that if address lines is to tell about the number of lines it can address. So okay, now you put 2 to the power 2, 2 to the power 2, what and all combination is available? 0 0 0 1 1 0 1 1, which is nothing but 4. 2 to the power 2 is 4. So total number of lines in memory I can address is 4 lines I can address. Okay, so this is and all is not sufficient for us. If I assume 2 to the power 8, okay, then 2 to the power 16, 2 to the power 32 and 64. That is why we are able to address more memory location. So memory location are addressable only by address bus. Okay, then comes your data bus. It is an external bus that carries data from R to the address. Okay, so I think you all might have seen a processor called 8085 where you have 16-bit address and an 8-bit data, whereas your address lines and data lines are multiplexed, which means there is no separate data lines. So there are address lines and data lines in which lower order address is shared both for purpose of address as well as data. So how you can do? So that is being done because whenever you declare an address, initially from the processor I will send the lower order address, then I will send the higher order address. If I am sending the higher order address, at that point of time lower of address is free, so I can use it for data. So that is why sharing is possible. A well known 2 mark question they will ask, what is ALU, which is address latch enable, ALE, address latch enable. So with that we are able to do that. Then what they did, why you want to go for sharing, let us have separate. So then what they have done, they have done a separate data lines and separate address lines. That processor I think you all know, first one came as 8085, then they came 8086. This 8086 is separate, you have for 16-bit address as well as data. Then what they did is this 8086 is address lines is also 16, data lines is also 16. So if the data lines is also 16, what is the problem faced is I developed the motherboard with 8085 where data lines are only 8-bit, and now if I introduce 8086, what happened is I have to throw the entire motherboard itself, because the motherboard has only 8 lines, data lines, whereas in 8086 what they did, they increased the data line capacity to 16-bit as well as your address also 16-bit. So all the motherboard itself has to be thrown into dustbin. So then they thought, why can't we have internally let the data lines be 16, whereas outside let the data line be similarly as an 8-bit itself. Then came 8088. It is a special processor where inside the processor there will have 16 lines, data lines, but externally it will have only 8 lines. So now what they did, the motherboard which was manufactured with the help of 8085 were able to be used by this processor also. Then we developed our technology from single layer to double layer, then double layer to multiple layer motherboards. Then there was no issue. We moved on from 8-bit, 16-bit, 32-bit, and nowadays it is more than 4 layer to 5 layer. You have your motherboard. So now it is 64-bit running. Okay. So this is about your address bus and data bus. Then comes your control bus. I think we all know what is control bus. That address latch enable read or write, then they might have called something called S0 and S1 lines. Okay, all these lines are put together, they are called as control bus, because they are going to control whether the lines is for address or is for data. Okay, then bus interface unit, it is an interface between the processor internal units with external bus. Okay, so it is like a junction. Usually it is made up of metal, and you will have gold tipped, because gold has a least resistance, so power loss will be less. Then comes MIEEE, memory address register. It is internally used by the manufacturer itself, so it will hold the address of the byte or the word to be fetched from the external memory. So you connect a memory external. See, for a processor always memory is external. So when you connect a memory external, there may be multiples of memory, and the multiples of memory, each memory you might have used till some instant. The next address of that particular memory will be brought and saved in memory address register. Okay, so a memory address register is nothing but a memory. It will have, say, let us assume 10 lines, and each line is allocated for each memory. So till what line you have studied in that particular memory, the next line will be in this register. So I can directly go to that particular line. There is no need to that I have to go from the first for each time. Thereby I will reduce the time taken. Okay, so all this is done only to minimize the time taken. Then comes MDR. It holds or bytes the word fetched from to external memory or input output address. So now it is for external. One before what we have seen is internal, and this is external. Then comes your program counter. I think you all know what is called program counter. You might have studied in microprocessor and microcontroller what is called as program counter. So program counter is nothing but I am started executing my program line by line, and in some case the next line to be executed will be there in the program counter. And I think you know when this program counter value will change is if there is any jump, call or return. Okay, if there is call instruction or jump instruction, what will happen is the content of this program counter will be moved to stack, and the new address from the call or jump will be loaded in the program counter. Let us assume, I think all this you might have done in MIEEE class itself. Now just we are refreshing, that's all. Okay, because just as an embedded system you should know again, so that is why I am repeating. So when you have for example at a line number 6000, if you add, okay, at line number 6000 you have an instruction called call 8000. So what will happen? Initially what is the first step? Opcode fetch. What is the opcode fetch you are doing? Opcode fetch you are doing for the instruction call or jump. Okay, I repeat, let us assume 6000, at line number 6000 you have an instruction called call 8000, which means I am going to jump to the line 8000. Okay, now the thing which you have to remember is program counter will be having what value when this particular line is being executed. When this line is being executed, or once this call is being seen by the processor, then your program counter will tell about 6001, because it is this call is written on the line number 6000. So obviously 6001 will be in the program counter. Now what you are going to do? You are going to jump to a location, say 8000. So after jumping, after completing the work, where you have to come? Again you have to come to 6001. But the program counter will be loaded with 8000 now. So the next value, that is 6001, will be moved to stack, and then the new value will be loaded in program counter. Then automatically it goes to line number 8000. There finally after completing you will have an instruction called return. So when you see return, what it will do is automatically it will go to stack, take the content and place it in your program counter. So program counter you are able to understand, it will tell about the next line of execution. Stack pointer, that will tell about the location, current location where you can move the content. See, stack pointer is different from stack memory. Stack memory will have the content, and the free location of the stack will be indicated by stack pointer. So in 8085 it is stack memory is decremented. Okay, program memory is incremented and stack memory is decremented. So first if you send a value to stack, then it will be decrement by the 1 and it will go to one step in forward. So then that address is being stored in a stack pointer. Then comes your instruction register. It takes sequentially the instruction code to execute of the process. See, again please listen, your processor doesn't understand English, doesn't understand hexadecimal, it only understands binary. So whatever you want to tell to the processor, you have to tell only in terms of binary. So he cannot understand the English what we write jump or what we type into the processor as 32, which is nothing but the opcode of jump. Okay, this both it will not understand. So what is actually done, whenever you give 32, it will take this 32 and it will compare with the data which is available. So for example, if you use 110 instruction, then there should be a 110 location inside for each. It will have, in terms of binary, it will have what you have to do. So that instruction is called as instruction register. Decoder is doing this work. He will decode. He will identify the instruction what is sent by the user, and then he will identify the equivalent code, that is called instruction decoder. Then instruction queue is, you might have studied something called pipelining. Pipelining is when you take first instruction, then after taking this instruction you go for execution. At the time of execution, what you can do, you can ask the processor to take the next instruction, that is nothing but fetching. So now at a time 2 work is being done. So you are going for pipelining. That till that you might have studied, but nowadays I can, at a time my processor can do n job. So that is n is called as queue, which means everything is kept one after other and they are sent in queue. This queue will normally break if there is any jump or call. Okay, if it is the queue of instructions, so that the instruction register does not have to wait for the next instruction after one has been carried out. So instruction register, it will send to this instruction queue and this queue will send one by one. Okay, next is arithmetic logic unit. I think you might have studied arithmetic logic unit, which is nothing but what is there inside an arithmetic logic unit. Only 2 blocks. One is called full adder, another one is called as full subtractor, because the operation which you are carrying out is only addition and subtraction in case of your 8085, whereas in 8051 microcontroller, mul instruction and divide instruction is being brought, but you can even do multiplication and division in 8085, where program line will be more. You will put like repeated addition, whereas they have reduced the number of instructions, that's all. And but the ALU doesn't have any block for multiply or divide. ALU will have a block only for addition and subtraction. Then comes floating point processing unit. What you have studied in MIEEE is only fixed point, which means it does not include any decimal points, whereas now advanced system is there. See, when you are launching a rocket, decimal point, after decimal point we will go for 30 digit or 40 digit, like 3.1 2 3 4 5 6 7 8 9 10, it will go to at least 30 digit. So in that case, the processor like 8085 or 8086 or 8051 cannot be used. So that type of processor are called as floating point processor, where it takes all decimal into consideration. Floating point registers, register set. So when you want to store, when you want a processor to be operated in with the decimal point, then all the registers also should have a capability of storing. So that is what we call as floating point register set. Then comes control unit. Control unit, what is the role of the control unit? This is similar to your brain. Okay, something is being viewed by your eye, that image is brought in and that image is sent to brain, then brain only will identify what is that. See, if I just say elephant, just close your eyes, you can imagine the entire elephant will come into your picture. How this is happening? That is because of the control unit. Similarly here, control unit is going to generate the pulse. What pulse I have to generate next? then which register should be turned on, which register should be turned off. For example, LDA 4500, your 4500 location as a content that has to be loaded. So at that time what you have to do, you have to select only the memory called accumulator alone and the rest has to be turned off. So you give a pulse to only accumulator. So what happens is whatever in there in the data line will directly come and sit in the place called accumulator. So that is the role of control unit. Then memory management unit, I have so many memory, how I am going to manage this memory, okay, that is called memory management unit. And again I will give a small example. You have a called a CD, okay, and you have a writer in your laptop or system, okay. Whether the CD speed is a fixed speed or variable speed means CD is rotated at only fixed speed, whereas when your writer moves from your center to the surface, what happens is it has to be moved with the same speed as well as the CD is rotated at the same speed. So now some locations it will just jump, there I cannot write because my speed will be very accurate when I am close to CD. When I move away from the till the CD end, then I can miss some portion. That missed portion as well as the portion where I have written will be identified only by memory management unit. Then application reset unit, it sets on chip register used during processing the instruction of the application program of the user. So it is only to reset all the register, means all the registers will be brought to 0. Then instruction catch. What is catch? Okay, first of all we should know what is in catch. Catch is nothing but it's similar to the cricket. Somebody is throwing and somebody is catching. There is a way by which I will throw. I can even continuously throw and you have to continuously catch. So catch is nothing but how fast I am able to get the instruction in queue. So okay, so when you say instruction, you call instruction catch. Similarly, how fast I am able to catch the data, I will say it as data catch. Then prefetch control unit. Prefetch control unit, it is unit that controls prefetching of data. So see, when starting it was only one instruction came in, that is been executed, that is been done some work. Whereas when you go for higher level, we told we will put pipeline. So when you put pipeline, you should have a prefetch control unit also. So for the next one you should have, okay. Then register window. Window is nothing but, see, you have a window at home. If the window size is very small, you can only view a small part of the real world when you open the window. That means, let us assume you are opening the window and you are looking outside. If the window size is so small, you can view only small portion. When the window size is more, you can view more. So here we say window register is nothing but how much register you are using, okay. A register window consists of subsystem of registers, with each subsystem storing static variables and status word of the task in the program thread. It is like little bit confusing, but the thing you have to understand is only register window tells about the total content of registers which you are using. Advanced processing unit, there are some processing unit which can work at very faster speed like multi-line superscale processor, and there are high speed that it can use or high instruction per clock cycle. Per clock cycle itself we can go for. So an atomic operation unit, it is reverse of our case. So the entire task is broken and given to each one, and each one will do and report it and they will give it to us. So time taken will reduce. So this is the structure you have to draw. So it is a sure 16 mark question if you write your test with 16 mark, okay. So you have to draw the various structural units. So I have discussed all structural units. So you have to write by drawing this particular diagram, okay. Then let us move on to embedded system characteristics. So what and all characteristics you should have? System should be real time. The program is preloaded into RAM or flash memory. Dedicated set of functions. Complex dedicated purpose program like algorithm, hardware and graphics. Multi-rate operation with different predetermined time constraint to finish the different operation. All this comes under real time. I will tell you when we see real time, then we will see because in all the places in embedded system we cannot say it is time independent. In some applications is time dependent. At that particular time you have to do that task, otherwise the entire system we call it as failure. Okay, so you are putting an embedded system in order to control a process, and if you are controlling, you cannot say always it is independent of time. Okay, in some case it is dependent on time. See, if you put a embedded system for washing machine, vacuum cleaner, refrigerator, that all is independent of time, that does not depend on time. We cannot say that washing machine should be turned on only at morning 4 o'clock, 5 o'clock and all. That is, we cannot say. But there are some applications, say with respect to satellite communication, with respect to data getting from GPS, with respect to data getting from satellites, all that case it is time dependent. If I am not on at that particular instant, I will lose the data. So I have to be always in on. So more number of hardwares, algorithm, graphics, multi-rate operations will be carried out, that we will see in detail when we see with real-time operating system. Okay. Then constraint of embedded system. What and all constraint? See, I cannot take memory as infinite or 0. For embedded particular application, for a particular task, what is the memory required, only that I have to take. So I should not go for more memory. So that is the first constraint. So you have to sit and work and prepare a program, then confirm that I have written a program for 2K, then only 2K memory is required. If I put 4K also, it is waste, because address lines will increase. When address lines is increasing, it takes more time, obviously it is waste. Okay, next is available processor speed. See, I have even in order of more than gigahertz, but my process required only in kilohertz. Then if I put a processor with which can work at that particular speed, again it is a waste. For example, let us assume I am going to control a 3-phase induction motor. So I may use V by F, variable frequency control. So by varying the frequency, I can vary the speed. So what is the maximum frequency here? 0 to 50 Hz or 0 to 60 Hz. What is 60 Hz? It is 1 by 60. In terms of time, tell me, it is only millihertz. So now even kilo itself is more than sufficient. I should not go for from kilo to mega, mega to giga and all. So I should not go for a processor which are working in mega here. I need a processor more than sufficient who is working in kilo. So the rate will come down, the entire setup will be cheaper to manufacture as well as all the things. Then meeting the deadlines. Meeting the deadline is again comes when with respect to real-time processor. That is also a constraint. Then performance. How fast is your performance? Power. Then comes your power management. See, I am selling a laptop for army, or I am selling a laptop for local, for commercial, or I am selling a laptop for some other. Say all these are not same, which means I should have a very high performance person who is been operated in army or rocket launching and all, where it doesn't require that much high performance for you, because your calculation are not so decimal to the point of 30 or 40. It is only 0.1, 0.2, 2 decimal or 3 decimal you will go, or even 10 decimal you will go. So that is what we say about performance. And this power, this is another fellow. See, if I am using a satellite, there I will use a microcontroller that will get the power from solar. So I cannot expect more power there. So my processor also should work at low power. So what we do is, in order to reduce your power consumption, I will reduce the voltage. Okay, so you might have seen a processor you have studied is 8085 with a 5 volt VCC. So if I want to reduce the power consumption of the processor, I have to come down the voltage. So that is why nowadays microcontroller and processors are available for even 3.3 volts to even there are some processor with the power supply 1.5 volt itself. Okay, so that is with respect to power. Then size, that we all know. So based upon the application only, I can decide the embedded size. Okay, like if you are manufacturing a small robo, like a robo with the size of ant, that has also arrived now. In that case, your processor size and all should be so small. Okay, that is not possible. But see the nature has have an animal called ant. Okay, you can see how small it is. It is not even 1/100th of our eye size. Okay, but if you keep a small piece of laddu on your table, within 5 to 10 minutes it will come and take. Okay, even we are unable to smell the laddu, we cannot. Okay, but see the nature creation. Okay, so we are trying to go till nature, but unfortunately that is not at all possible. But to some extent we have to reduce our size. And design and manufacturing cost, see, if so sophisticated if I go, then design cost will increase and manufacturing cost will increase. That leads to so many issues. Okay, so that you have to take into consideration. So till now we have completed the first part of today's session. Then comes the selection of selection of processor. Again I say it purely depend upon the product which you are developing. Okay, see, and last class itself I told you all have to think like a CEO of a company. So when you want to prepare make an embedded product, processor should be properly selected, or in other words, whether you require that features in your embedded system, then only you have to go for that processor. If that is not at all required, you are not supposed to go, because the cost will increase, again the performance will come down. See, putting a 12th standard boy in an LKG classroom, you cannot say that he will get always 100 mark. But there the capability is very high and the thing which is very less, then you are wasting a fellow. Okay, so that is what selection of different system require different processor features. The processor is selected from the following consideration: number of instruction set. Whether you require high instruction set, you have to go for high instruction set processor, or I think you might have heard called RIS, reduced instruction set code processor, where the instruction will be less. Then maximum bit in operand in an operation, that is 8-bit or 16-bit or 32-bit or 62-bit. Then processing speed, what speed you want, whether you want in order of kilo, mega or giga, that you have to. Then the ability to solve the complex. So initially your processor which you have studied can do addition, subtraction, multiplication, division. Now you have matrix multiplication, matrix manipulation, then you have square root, exponential, such calculation is also required. So the ability to solve the complex algorithm. So if you are increasing your complex algorithm, again you have to go up in the process. Okay, a processor give high computing performance when it has pipeline, superscalar architecture, superscale, prescale and all, I think we will see in upcoming classes. And pipeline I have already told, pipeline which means one after other already come in, so you are working parallelly, which means pipelining is nothing but parallelly. Prefetch, catch register files. Then RIS is reduced instruction set core architecture. That last 3 bulletin we are saying what and all is available, but you have to select only depending upon your requirement. A processor with a register window provides faster content switch in a multitasking system. So when you go for multitasking, obviously you should have more registers. See, in 8085 I cannot do matrix manipulation and all, because the number of register I am having is less. If you want to do that and all, you have to increase the number of registers. So that is what I have already told, that is register window. Then processor as auto shutdown feature for its use. What is meant by auto shutdown is avoiding wastage of power. If nothing is been done, you are not touching your laptop at all for more than 30 minutes. So your laptop should identify that at least it should go to sleep mode. In sleep mode, at least the display power will be cut off. Okay, and there are some cases where you call auto shutdown itself, which means your processor will be continuously checked, and if your processor gets stuck somewhere, then it may automatically go to shutdown and then it will restart. Okay, in some case it will shut down and it will report, in some case it will shut down and restart. Processor with burst mode access external memory fast, which is nothing but taking data at a faster rate. Okay, that's all. Then software design coding is over. So now what you have done, I think I have started for manufacturing an embedded based washing machine. So what is the way I will do is, I will sit and write the program. So once the program is over, then ROM image file is ready. ROM image file is, the program should be written only in ROM, not RAM, because if you write it in RAM, some other your competitor will loot the program and he will just copy and paste it in his embedded system, and he will start selling the washing machine. Then you lose your customer. So what you will write inside the ROM, read only memory, only you can read. Okay, so file is ready. The hardware designer of the system. So now that's all. I will totally cut the software people now. That is why I told, when you worked as an hardware embedded system person, and you can do, the IT fellows, they can come till as a software designer in an embedded system. Okay, they know only what is coming, what you have to do, what will go out. That's all. How you are going to connect it from a sensor, or how the output is going to be connected to sensor and all, that fellow doesn't know. Only that is our role. So once he write the program, and if he says ROM image file is ready, then ask him to quit. Hardware designer now come into picture. Then he will start thinking, okay, for this program, what is the memory required, what is the use, how much size of each should be used. All this will be decided by your person called hardware person. So now we will see what and all memory available. I think this you already know. Just we will refresh. There is called as ROM, read only memory. Then EEPROM, difference between ROM and EEPROM. ROM you can write once, EEPROM you can erase with an help of ultraviolet rays. Okay, and that is difference between EEPROM and EEPROM is that ultraviolet rays can be passed only one time in case of EEPROM. That's all. Again, then it will become ROM, read only memory. In EEPROM, I can erasable. So every time I can go and sit and erase and write. So when I will do this, so initially when I am writing the program, I will go with EEPROM. So once the program is finalized, that's all. It is working correctly. No more alteration is required. Then same program will be written inside EEPROM. Okay. Then comes RAM. RAM is, at the RAM time I may get so many datas. I will store the data. I will process the data. So now to store, I cannot store in RAM I will store. Okay. So random access I will use, whenever I want I will erase. Then ROM device, then EEPROM device. See, first we have shown with internal. So that is internal of your motherboard. Now you say external. Instead of saying external, I am saying it as ROM device, EEPROM device, EEPROM device. I think you might have seen some software engineers in their chain, they will have like a small pen drive which shows a number, and all that are like EEPROM devices. Then come flash device. Flash device is very fast rate of writing and cleaning. It is like a pen drive. Okay, and RAM pen drive. Then come distributed RAM. This is nothing but, see, when you take an IT company, there is n number of systems connected in LAN. So n number of system means all the system can store. So I will distribute the content and save it in all the system, and whenever I want I will use. Block RAM is nothing but, so distributed RAM is my client side and block is my server side. Okay, Google as a server, so that is block RAM. Okay, distributed RAM is Google sometimes takes the content from your laptop and show it to some other fellows. That is called distributed RAM. So these are the various types of RAMs. So selection of RAM, masked ROM and EEPROM stores the embedded software. So embedded software is only stored in this two types of memory. No other memory will be used to store the software. EEPROM is used for testing. That is what I told. When you are in testing processor, you may change your code. Some light code change will be there. At the time I will go for EEPROM. Flash stores the result. So flash memory is RAM memory. So I told pen drive. So whenever you type a word file, store it, then what you will do? You will store it in flash, like in your pen drive. So you will store byte by byte. RAM is mostly used in SRAM. Then you have SRAM, DRAM. All that is some advanced methods of storing. Okay, let us move on to third topic of discussion today, which is nothing but DMA, direct memory access. The input output device need to transfer a data of other system to the memory address in the system. The system may also need to transfer data to the input output device. So direct memory access is required when a block of data is to be transferred between the two systems without the CPU intervening except at the start and at the end. So I have a CPU. CPU has n task, and CPU cannot just sit and do only copy and pasting work. For example, you have a pen drive as well as CD. You want to take the content of CD to the pen drive. At the time, what the processor will just sit and just transfer from CD to take one by one content of CD and putting in pen drive. Whether this CPU will take care, if it is doing, then it is waste of time. So now what that CPU will say, okay, fine, the person, it will call for this DMA person, ask him, see, he wants the content from this location to this location, kindly transfer. Okay, then he will send the clock pulse, the direct access memory will send the clock pulse, it will increment the address of one by one, take the content and move it out. Okay, so that is called DMA. So you can see here, there is CPU, then there is a memory which is outside and the device is there. Okay, let us assume this is the internal memory, or let us assume this is CD, let us assume this is pen drive. So now what will happen is, first of all, you will insert pen drive and you will copy a content and then go to the device and paste. At that time, this DMA will go for a request, then CPU will grant. Once this grant is given, thereafter CPU is not supposed to use data lines and address lines, because it can do any internal work, but it should not touch the data lines and address lines. So now data lines and address lines will be controlled by this fellow called DMA. So he will take care of data lines and address lines. Thereafter, the CPU will not touch the data lines or address lines. Now this fellow will decide from where to where you are writing, whether it is read or write, this fellow will tell. Then this fellow will give the clock to these two devices. For each clock, the content will be transferred, either content from the device to memory or memory to device. DMA support three modes of operation: single transfer at a time when the release of old of a system bus, then more number of data at the same time, then bulk transfer. So single byte, a group of bytes, or very bulk of data. Okay, DMA transfer is facilitated by DMAC controller. So it is not related with your processor, so it is a separate intelligent fellow. So that is why you put a word called controller. So DMAC controller. Data transfer occur efficiently between the input device and the system memory with least processor intervention. So processor will do some other task. See, this is usually you copy a content from a CD to pen drive, and whether you are sitting and watching what it has been done, no, you will just go to Internet Explorer, you do some other task, you go to some other word file, you sit and type. So that is what we say here. Okay, so that is why DMAC is required. So you ask your pen drive to copy into your memory, and then you start doing some other work. So that some other work is done by your processor, and this copying work is done by DMAC. Okay, a typical DMA controller includes three registers: starting address register, length register, and status register. I think you all know what is status. Status is nothing but at current situation how much is being transferred, and the length register will tell about the byte length of that particular device, whether it is 8-bit, 16-bit. Then starting register address. All these three will be holded by DMA. Okay, so that is being written here: CPU, DMA, bus. Initially you will ask for bus request. Bus is nothing but data lines and address lines. I am requesting the CPU. CPU, once it will ask to wait, it will complete it process related with the data lines and bus line. Then it will say, okay, you start. Then once you are allowed to start, then CPU will not use address lines and data line. Once the entire data is been transferred, again I will come back and CPU will use my data lines and address lines. Okay, so this is just the same way I have written, only difference is here you have a processor, Then bus interface unit will tell about whether you are going to use or not. This DMA, I will ask for request, I will get acknowledge. Only if I get acknowledge, I can start my work. If the processor is not giving acknowledge, then it is understood that already processor is doing some other task with address lines and data lines. Once this acknowledgement is done, then this fellow will take care of this address line, and the content in the RAM will be stored to the device with the help of this DAC. Okay, so with this, let us stop the today's discussion. So